Good morning. We're going to talk this morning about an environmental issue that is quite prominent in our country and in our culture, and that, of course, is climate change. Climate change, formerly called global warming, is an issue that you'll hear a lot about, you'll see a lot of propaganda about, as you can see from the slide. Many times we see pictures like this, the world's on fire, or we'll see pictures of scorched earth and severe drought, all portrayed as a climate crisis or a global climate crisis that we need to be concerned about, that we need to do things about. So let's talk today about climate change. And again, as we're approaching environmental issues, where should we begin? What do we base our viewpoint on? And that is the Bible. So let's go to Scripture and remember what is the foundation of a proper view, a biblical view of the environment. Here's the biblical view of the environment again. God created it and controls it. He determines our place in it. So when we deal with climate, when we deal with environmental issues, we need to begin with a biblical worldview, and that biblical worldview begins with creation. So if we're going to have a proper view of the environment, we do need to remember and emphasize the fact that God created the environment. And as we try to understand what climate change involves and the issue here, we need to begin with what is the atmosphere and so forth. So let's begin with the atmosphere. And of course, here's a verse in Jeremiah. He hath made the earth by his power, he hath established the world by his wisdom, and hath stretched out the heavens by his discretion. So this verse, of course, is dealing with creation, and it is specific to the atmosphere. So the atmosphere was created by God, and the atmosphere was designed, every part of the atmosphere, the composition of the atmosphere, the thickness of the atmosphere, all of that was designed by God. Often you might see environmental information that starts out with evolution and has the idea that it's taken millions of years for the atmosphere to develop into its present state. Well, no, that's not the case. We know that's not the case. We know that God designed the atmosphere, and God designed the atmosphere for a purpose. So beginning with creation, we know the atmosphere was created on day 2. This is found in Genesis 1, 6 through 8, where God literally stretched out a firmament. What is the atmosphere? Let's have a definition of the atmosphere and understand the parts of the atmosphere and what the atmosphere is supposed to do. And can man affect the atmosphere to the extent that our climate change proponents are saying? The atmosphere then is a blanket of gas that surrounds the Earth's surface. Here's a good photograph of the atmosphere from outer space. And of course, we've said that God designed the atmosphere. Everything about the atmosphere is designed to sustain life on Earth. Beginning with the gases of the atmosphere, you probably remember from grade school and junior high science that the Earth is composed of nitrogen and oxygen, about 78-80% nitrogen, then oxygen, and then we've got some trace gases. So you can see the composition. God designed the atmosphere to be about 78% nitrogen gas, which is a very inert gas. But then also we have 21% oxygen, and then we have our trace gases. Of those trace gases, the main component is carbon dioxide. But keep in mind that this carbon dioxide is only 0.1% of the gases of the atmosphere. And then we have some other gases involved here. And these gases, nitrous oxide, methane, ozone, and of course carbon dioxide, are the infamous or famous greenhouse gases. But overall, the bulk of our atmosphere is composed of nitrogen and then oxygen. Also, God designed the atmosphere. We have different layers, the outermost being the thermosphere. The lowest level of the atmosphere is called the troposphere. This is where all of our weather conditions take place. So you can see the design of the atmosphere with its different layers. Here's another slide that illustrates the troposphere, then the stratosphere, then the mesosphere, and the thermosphere. So, if we're dealing with the atmosphere and we're trying to understand the issue of climate change, let's think about why we have an atmosphere. Why do we have the atmosphere in the first place? Of course, this is obvious. We have to have air to breathe. We need protection from cosmic radiation. But then the third purpose of the atmosphere is where the climate change, global warming issue comes into play, and that is to heat the surface of the earth. God designed the atmosphere to protect us from harmful radiation. So it is more than just what are we going to breathe, we need oxygen. But God also designed the atmosphere as a thermal blanket to heat the surface of the earth. What would happen if we didn't have the atmosphere? Here's one of my favorite pictures of the moon. But obviously the moon does not have the atmosphere that the earth does, and we are all familiar with its pocked, crater-marked surface. If we didn't have the atmosphere, no air to breathe, no protection from cosmic radiation, and of course, extreme loss of heat between daylight hours and the dark hours. So, as we're dealing with the atmosphere, we want to keep in mind that God created it, and He created it with a design. And God's design works very well. God designed that atmosphere to warm the surface of the earth. And really, do we think that man, even with all of his industry and all of his agriculture and even all of the pollution, can affect and change the atmosphere to the extent that our global warming, now climate change, environmental activists are saying? Sometimes the Earth itself is referred to as being the Goldilocks planet. If you're familiar with the story of the three bears, you remember that Papa Bear's porridge was too hot, Mama Bear's porridge was too cold, and Baby Bear's porridge was just right. So the Earth is just the right distance from the sun. The Earth has just the right atmosphere to sustain life, including human life. And as we continue thinking about climate change or global warming, what is climate? We've talked about what the atmosphere is, and keep in mind the atmosphere was designed by God to not only provide the air we breathe, to not only protect us from cosmic radiation, but also to warm the surface of the earth in an even manner. So atmosphere obviously affects climate, if not determines climate. What is climate then? When we talk about climate, what are we referring to? Here's a definition. Climate can be defined as the average course or condition of weather at a place, usually over a period of years, exhibited by such things as temperature, wind patterns, and of course precipitation. So the thing that I want to point out about climate is the fact that we are dealing with weather. We're dealing with overall weather patterns, or the average course of weather throughout the year in a particular place. So my question can be, and you'll see it later on, we're going to talk about, can we even refer to global climate? I think climate is more properly studied as the average course or condition of weather, overall weather patterns in a particular place over a period of time. So when we deal with environmental issues, we do have to deal with atmosphere and climate. But can we refer to as climate threat? Can these issues be referred to as climate threat? Do we have a global crisis looming on the horizon? Climate threat. What climate are we talking about? Are we talking about global climate? Can we even define climate globally? Can we even deal with the complexities of climate on a global scale? Of course, now this issue is referred to as climate change. Coming around the 1990s and in the 2000s, we had global warming. Prior to that, when I was growing up in the 1970s, we had The environmental issue of our day was not warming, but rather cooling. Here's a newspaper clipping from the 1970s. Significant shift in climate scene. New ice age dawning. All right, did we see a significant shift in climate to a cooling trend in the 1970s? Maybe we did. But now we are seeing a climate shift, a warming trend. So this idea of global warming and now climate change is just another environmental issue that is being blown out of proportion. Here's a Newsweek article, April 28, 1975. Again, warming of the cooling world instead of the warming world. And of course, you can see we have a graph here that's showing a decrease. It kind of looks dramatic, a dramatic decrease in global temperatures in the 1970s. So my question is, what is really happening? And to answer that question, I want you to keep in mind the tactics that we've dealt with in earlier lectures. We need to be aware of what's going on and so forth, and be looking for these tactics that are employed by environmental activists. There's the first tactic, manipulation of facts and data to the point of fabrication. Prediction of dire consequences and scare tactics. You remember the picture we began the lecture with, a globe on fire. Okay, we're going to portray climate change as a global catastrophe. In fact, recently, the famous scientist Stephen Hawking is talking about the fact that we need to find another planet within the next 100 years, or we're going to become extinct just like dinosaurs. All of this is part of environmental tactics. We're predicting dire consequences and employing scare tactics. Do we really need to find a new planet in the next 100 years or face extinction? I don't think so. Then the third tactic is blaming the wrong causes. Human beings are leaving carbon footprints. Industry is out of control. Agriculture is out of control. And of course, the population is out of control. And because we view these issues as being caused by overpopulation, overconsumption, too much industry, and so forth, we're going to propose the wrong solutions. So remember, scare tactics. What happened to the ice age of the 1970s? By 1980, 1990, we are no longer looking at cooling trends, so we're not having the dawn of a new ice age. Instead, we have global warming. And as 2000 came along, the global warming issue became more heated and became more of a dire problem. But then 2010 and following comes along, and all of a sudden we're not seeing a drastic warming trend anymore. And so we have to rename our crisis. Well, we had the dawning ice age, then we had global warming, now we have climate change. That way we don't have to specify exactly what's going to change. We can still just promote environmentalism as a global catastrophe waiting to occur. So what's going to happen in the future? Are we still going to have climate change? Are we going to go back to global warming? Are we going to go back to a new ice age? I don't know what the future is going to hold, but that's why we need to begin with the Bible. We need to have a proper view of the environment because these issues will change from time to time. Who knows what's going to happen by 2040? And you remember, why did we switch from global warming to climate change? And that is because the warming patterns that were predicted simply were not coming to pass. Everyone remembers winter 2014. And of course, we had a very cold winter, and much was made of the polar vortex because we had such a cold January in the winter of 2014. What was happening in 2014? You can see the cause of the polar vortex is dealing with weather, not with some new global problem. So you can see here we've got the Arctic blast, because there's so many different issues involved in climate. There's so many different interactions in the environment itself. So I think that what's really happening is that we are using whatever environmental issue or problem that we can to promote a political agenda. So what's really happening? If you think about science, science is all about questioning. Scientific advances have historically been made by a small amount of scientists questioning what would be the status quo. So as we are thinking about climate change or global warming or whatever the issue may be, with global warming, let's question what we hear in the news. Let's question what is being promoted by educational institutions. We need to question what we read, hear, and what we see, and especially we need to question what is being promoted by the entertainment industry. So questions to consider. If science is all about questioning, let's take a step back and let's take a closer look at what's really going on with climate change or global warming. First of all, is it global? Then, is it warming? What do we mean by warming? Is it man-made? Is it our fault? Are we all leaving carbon footprints? And then finally, is it even a problem? Let's address the first question. Is it global? And this brings out further questions. We want to question things that we see in the news. We want to question things that are being promoted by Hollywood and other aspects of the entertainment industry. Can we even consider climate on a global basis? Or is climate more regional? Or is climate just different weather patterns that occur in different portions of the earth? So climate has always involved generally prevailing weather conditions of a particular region. Can we deal with climate, and essentially can we deal with weather patterns on a global basis? Well, at best, global climate is an average of all the world's regional climates. So anything that we're doing here is simply an average of what's going on globally. I really don't think that many of these issues can be considered as one global problem. So at best, climate change is a change in the Earth's overall climate. So my question is, what is the Earth's overall climate? How do we measure it? Let's go to the next question. Is it warming? Well, that depends on what you mean by warming. And it also, unfortunately, depends on who you ask. So, is the Earth warming? And the answer to that is not consistently. And what's really happening is the Earth is experiencing and has been experiencing cyclic warming trends, cooling trends, etc. So can we say that there's a steady increase of global temperature? No, we cannot. All we can say is that the Earth is doing what it's been doing for decades and decades and decades, and that is experiencing cyclic warming and cooling trends. Are these affected by industry? Are these affected by cutting down the rainforests? Are these affected by increased agriculture? Well, the answer would be on a local level. And overall, the Earth itself has remained relatively constant. Yes, there are cyclic times where the temperature goes up a little bit, but then they're followed by cooling trends and so forth. I really don't think that no matter how you measure it, you can legitimately say that the Earth is increasing in temperature overall. This, of course, brings up another question. Can temperature even be measured accurately on a global basis? Well, the answer to this question is becoming more and more, yes, we can. We have a lot of satellites in orbit around the Earth. We can take temperature readings from outer space much more accurately and so forth. So can we measure temperature on a global basis? Yes, we can measure temperature throughout different regions of the Earth, but can we even accurately average it? Does that even give us a picture of what's going on globally? Can we even describe climate on a global basis? And even if there is a warming trend followed by a cooling trend, does this even make that big of a difference overall? Well, the effects of so-called climate change, changes in global temperature averages, are difficult to predict or quantify. So is it warming? Is worldwide temperature really rising? What does warming mean? What do we mean by warming? How much warming? 2 degrees Celsius? How much does that affect the Earth when we're talking on a global scale? And how was this temperature measured? There's different means of measuring temperature, especially when we're trying to average it globally and trying to make sense of it globally. What does that even mean? What's the time period? Are we centering in on a decade or two, or are we looking at overall warming patterns and trends? And who is being asked? Many times you can find information on both sides of the issue, where some scientists will say, well, now we're experiencing a cooling trend, and others will say, no, we are warming, and so forth. So is worldwide temperature rising? We look at this graph, and it looks like we've got a warming trend going on. But then, if you examine the y-axis here, you can see that we're dealing with a temperature change of 0.25 degrees. This says average temperature anomaly. So this just means odd temperatures, change in temperature. We're seeing slight changes of temperature. And again, look at the scale, 25 hundredths of a degree Celsius. Here's another temperature scale that actually shows no global warming for the last 17 years, 9 months. So you see the point here. It's difficult to even answer the question, are worldwide temperatures rising? Is there a warming trend? And you can see why I asked the question. It depends on who you ask. And it depends on how you measure it. And it depends on the time period. So the issues with climate are definitely complex. The next question, is it man-made? Is it our fault? Are we causing global increase of temperature on what is portrayed as a catastrophic scale? Is it man-made? Well, let's think about it. What are the greenhouse gases? What part of the atmosphere, what roles do they play in the atmosphere? How do these gases get in the atmosphere? What is their source? What things provide the most greenhouse gases? And then how much impact does increase in CO2 have on global temperature? Are the levels of carbon dioxide rising in the atmosphere? What are the answers to some of these questions? Is there such a thing as carbon footprint? Well, let's look at the greenhouse gases. We don't hear about this one a whole lot. Water vapor. Water vapor is which of course would be related to cloud cover and so forth, and humidity, both. Water vapor, of course, would be the humidity in the air. Clouds form when the water vapor is able to condense. So we do have water vapor as our first greenhouse gas. And with water vapor, you're probably familiar with the extreme temperature changes that occur in the desert, where we don't have a lot of water vapor in the atmosphere, where there isn't cloud cover. You know, probably at least have heard about how during the day, desert temperatures are going to be very high. But then you're going to have a definite and distinct drop in temperature at nightfall. And this is because of lack of water vapor in the atmosphere and lack of cloud cover in a desert region. So water vapor is a greenhouse gas, even though we're not hearing about it nearly as much as we are carbon dioxide. Ozone. Ozone, of course, in the upper atmosphere is a good thing. It helps protect us from certain wavelengths of ultraviolet radiation and other cosmic radiation. It is important. But at lower levels, ozone is a pollutant and is a greenhouse gas. Number 3 on our list of greenhouse gases, of course, is the infamous carbon dioxide. Is carbon dioxide a greenhouse gas? Does it contribute to the functioning of the atmosphere as far as heat retention and so forth? Yes, it does. Methane is another contributor to the greenhouse effect in the atmosphere. Nitrous oxide would be another. But keep in mind that these are trace gases that make up 0.1% of the gases in the atmosphere. You can see of that 0.1%, most of this is carbon dioxide, and we have helium and other noble gases, nitrous oxide, methane, ozone. Water vapor is not even considered to be one of the gases that make up the trace amounts. That's because the amount of water vapor in the atmosphere is regional and more local and also at lower levels. So how do these gases get into the atmosphere? Many times environmental activists will ignore the natural sources of carbon dioxide. Natural sources of carbon dioxide include respiration. We all know that animals exhale carbon dioxide. We also will get carbon dioxide from decomposition and so forth. What we see emphasized and highlighted by environmental activists are the man-made sources, fossil fuel burning. Of course, the biggest thing that we hear about as far as fossil fuel burning would be the coal-fired electrical plants, and even also the carbon emissions from vehicle exhaust. So fossil fuel burning is promoted as a big source of carbon dioxide, as well as manufacturing and even agriculture and even certain types of ranching and so forth. But of course, with ranching, they're dealing with methane, animals giving off methane into the atmosphere. So let's take a look for a minute at this picture. What we kind of don't hear about is the massive amounts of carbon dioxide that are exchanged between the atmosphere and the oceans. Of course, that's going to involve photosynthesis of the phytoplankton and all kinds of different complex interactions going on. We also have decomposition contributes to carbon dioxide, photosynthesis, and of course plant life involve the carbon dioxide exchange with the atmosphere. And right here in the middle, of course, we have our anthropogenic carbon sources. And that, of course, is where our environmental activist friends will center in on how much carbon dioxide we are putting into the atmosphere. And I think if you look at it overall on a global scale, the anthropogenic carbon sources aren't anywhere near to be compared with that of the ocean. So climate change, global warming, whatever we want to call this issue, is it global? Is it warming? Is it man-made? And then the final question here would be, is it a problem? Is it possible to predict the dire consequences that we hear about from climate change? How much of a problem is a 2-degree increase in Celsius, a 2 degrees Celsius increase in global average temperature? How much of a problem will that cause? Can we predict this? So as we're dealing with this 2-degree increase in global average temperature, what time period are we looking at? If we look back into the 1970s, go further and further back, even into one year that you'll see a lot of is 1880. Do we see this 2-degree temperature change? Can we even then predict the results of it? What time period are we talking about? When? Is this increase still happening? What happens when we start looking back to 1880 and forward to 2020 and so forth? What is the source of our information? Where are we getting these predictions? Who is making these predictions? How are they making these predictions? Or is this just another scare tactic? One thing that is often prominently promoted with climate change or global warming is the idea of the polar ice caps melting. All right, so let's talk about that question. Let's look at this for a minute. Are the polar ice caps melting? We could go through again and ask those same questions. What do we mean by melting? Which ice caps? Are we talking Arctic, Antarctic? Are we talking Greenland? Or are we talking further up in the Arctic Circle? Well, of course, you can find information on both sides of this issue. Okay, we are alarmed at the Arctic glacier melt. But then again, I can find information like this. Record return of Arctic ice cap as top scientists warn of global cooling. Oh, wait a minute. I thought global cooling was in the 1970s, but here I'm looking at August 2012 compared to August 2013. So are the polar ice caps melting? Well, depends on what you mean by melting, depends on how you're measuring it, depends on which region you're talking about, it depends on who you're asking. Of course, you can get pictures off the internet that show both. I can pull this picture off the internet. Are the polar ice caps melting? Well, I think to try to say that the ice caps are consistently melting is incorrect. What can be said is that we have, very similar to the idea of temperature, we have the ice caps melting, and then the next year we might have more freezing, followed by a period of melting, followed by another period of freezing. So I don't think that we can say the ice caps are melting, not overall. And if the ice caps do melt, okay, is that going to be a problem? What is the effects of a small temperature increase? What are the effects of that small 2 degree, if that, increase in global temperature? What are the effects of that? As I said earlier, these effects are difficult to identify, to predict, and certainly to quantify. But of course, the news media and the entertainment industry would have you believe that these are solid facts. I would have you to believe that this is a climate crisis. Could even a 2 degree Celsius increase in temperature, could some of the effects even be beneficial? How would a slightly warmer climate affect different regions? Is it possible that we could have longer growing seasons in some of the agricultural regions of the earth? Is it possible then that we would use less fossil fuels in the colder regions of the earth because we'd have slightly milder winters? Could any of these effects even be beneficial? Is this question even being examined? So what is really happening? Are we facing climate crisis? Or is there really such a thing as climate change? Now keep in mind what we're saying here is very controversial. I would be considered a denier. I'm denying climate change. I've got my head in the sand. I'm just the same as the historians who want to deny the Holocaust, or those that would deny that Apollo 11 landed on the moon. It's all a matter of how environmental activists are portraying the information. Is global warming occurring? Well, we're hardly even calling that anymore. I like this cartoon because it illustrates what I'm trying to say. Okay, here we are in 1970, 1980, in that decade, we've got global cooling. We've got the dawn of a new ice age, according to environmental activists. Then we see a warming trend, so all of a sudden it's now global warming. We've got to reduce our carbon footprint. Governments have to get involved. We need to have international environmental summits, et cetera, et cetera. Well, then the warming's not quite working out for us, so we'll have to call it climate change. Or maybe now we should even call it climate disruption. And look at the little boy here in this cartoon. A lot of times these more political cartoons just portray a message very cleverly. It's called weather. So let's talk about climate change. How would environmental activists or even extremists define climate change? Notice the wording. Climate change is dangerous, man-made global warming. Well, I have a problem with that. Is it dangerous? Is it man-made? Okay, so now we're calling it climate change, or dangerous, instead of dangerous man-made global warming, we're renaming it to hide the fact that there is far less warming is happening than was predicted. Of course, environmental activists continuously bombard us with pictures like this, where in reality their computer model, their prediction, is simply has not occurred. So here we are with different scales that I showed you this one earlier. Observe global temperature average. Well, that's one way we can measure global temperature, is observing it and averaging it. And when that is done, you can see from this person that produced this graph that there's no global warming over the last 17 years. We've got actual decrease in observed global temperature average. And of course, that's why we have to refer to our climate crisis as climate change and not global warming. Another way we can measure global temperature is global surface temperature. This is a graph of global surface temperature deviation. Look at the title right here, sizzling. And we even have it all marked in red. What is that? That's a scare tactic. That is overstatement of fact. And to my mind, when this type of tactic is employed, it's because we're trying to hide the fact that the science really isn't backing up what we say is happening. I think it's poor science when you have to revert to scare tactics and you have to use the terminology that we see continuously from our environmental activists. Sizzling right here, red. But then if you look at the y-axis, look at the scale. This is 1 degree Celsius. And each of these points on the graph are again at hundredths, 25 hundredths, 50 hundredths. So we've got half of a degree Celsius here. So our global surface temperature deviation in the 20th century, here's 1880, here's 2015. We can see that the temperature changes. It's deviating from the norm, whatever that would be, by less than a degree. So what do we have here? This shows dramatic cooling prior to looks like 1935-ish. Then we have a little bit of a warming blip here in 1940, and then we have some cooling. This looks pretty dramatic until you look at the scale. And of course, we've got to highlight this as red, and we have to say sizzling, just to give people the impression that global warming is a problem and global warming is happening. Here's another way, average temperature anomaly. And this is the first graph that I showed you, and you can see it looks like we've got some warming. But let's examine it. And that's one thing about a lot of the science, so-called science behind global warming, behind climate crisis, is that it just does not stand up to prolonged scrutiny. And when you start looking at the scale here, again, is the same. 25 hundredths, 50 hundredths, which is basically half a degree Celsius. So when we talk about global warming, what is global warming? Well, according to environmental activists, it's dangerous, man-made increase in temperature. But really, when you think about it, global warming is actually what the atmosphere, it's actually what the atmosphere is supposed to do. Remember, God designed the atmosphere. It's not some chance of evolution that somehow life began on the Goldilocks planet that just happened to be the right distance from the sun, that just happens to have an atmosphere that sustains life. No, global warming is part of what the atmosphere was designed to do. The atmosphere does what God designed it to do. It does warm the Earth's surface. It's designed to. So global warming, in my mind, should be just the natural heating of the Earth's surface by the heat-trapping particles, heat-trapping properties of the atmosphere. Okay, the atmosphere has heat-trapping properties because that's what it was designed by God to do. So if we talk about global warming, it is the natural part of what the atmosphere is supposed to do. You can see what happens. This again involves what is the purpose of the atmosphere. One of the main purposes of the atmosphere is to warm the Earth, to prevent those drastic drop in temperature between daylight and night surface temperatures that we see on the moon, or what we would see if we had no atmosphere. So a lot of what happens with the atmosphere is what the atmosphere is designed to do. And do we really think that we're going to make a change to the atmosphere by too much carbon emissions, too much fossil fuel burning, et cetera, et cetera? So what happens, solar radiation comes in. A lot of it is going to bounce up the upper atmosphere. Again, that's what the atmosphere is designed to do. And then it's going to pass through the atmosphere and it will be absorbed by the surface of the Earth. And then as it's absorbed, it will be re-radiated, pretty much as infrared radiation, back into the atmosphere. And some of that will pass back through and some of it will be trapped by the greenhouse gases. But again, that's what the atmosphere is designed to do. The atmosphere does have heat-trapping properties, and it's supposed to. Oftentimes, this will be referred to as the greenhouse effect. We'll call it the greenhouse effect, but in reality, it's a whole lot more complicated than a single greenhouse structure that we're familiar with. So here is the greenhouse effect. And this is a natural heat-trapping property of the atmosphere. The atmosphere is simply doing what it's designed to do. And here are the steps. A little bit more detail. We've got incoming radiation from the sun. A lot of the harmful rays of the sun will bounce off the outer atmosphere just like it's designed to. It will pass through the atmosphere and it is absorbed by the Earth's surface. And of course, what is the composition of the Earth's surface will change from region to region. And so then we will have different levels of heat absorption by different types of surfaces. You're probably all familiar with urbanization, and one of the effects of urbanization is that concrete and asphalt and so forth is going to absorb more heat and change the actual how much heat is going to be trapped. There is a lot of heat trapped around urban areas because of the surfaces and the absorption properties of those different surfaces. Of course, it's going to be a lot different when you're in a rural area and you have more vegetation and so forth. But again, these are local effects. These are not global climate crises. So then we will have surface absorption, and then the surface will absorb certain part of it, depending on which surface it is, and then it will also re-radiate back into the atmosphere. You've all experienced the heat coming off of pavement, especially blacktop. All right, and that is a normal part of how cosmic radiation interacts with the Earth. And then as it is re-radiated, it will be trapped. And this is the actual greenhouse. This is the actual greenhouse effect, is the fact that these gases in the atmosphere do trap the re-radiated infrared radiation and can radiate it back and so forth. And of course, this is part of the purpose of the atmosphere. So if we were to summarize the greenhouse effect, here's the first step. Visible light, all of the radiation coming off the sun, not just visible light, but the light will pass through the atmosphere and will be absorbed by the Earth's surface. Then this energy will be re-radiated in the form of infrared. All right, and most of this infrared radiation will not pass back through the atmosphere. It will be trapped by our so-called greenhouse gases, which then can also absorb it and re-radiate it. That's how it's actually trapped. And this does trap heat, and it does warm the earth. And that's what it's designed to do. But sometimes what's ignored are other factors involved with temperature, especially if we're trying to deal with temperature on a global scale. What about other interactions? What about weather patterns? What about ocean currents and so forth? I think we can't discount the fact that the heat can be dispersed and so forth by convection currents of the different wind patterns in different portions of the globe. So those greenhouse gases that actually are supposed to be analogous to the glass of our greenhouse are water vapor, ozone, and there's carbon dioxide, methane, and nitrous oxide. But keep in mind that these are still in the category of trace gases. So as we're talking about climate change or global warming, is it the issue that environmental activists are portraying? Is it a big problem? So my question is, what's the big deal? If the greenhouse effect is what the atmosphere is designed to do, what is the problem? What is the environmental issue that we're dealing with? Can we do something about it? Do we need to do something about it? Are we drastically increasing greenhouse gases by our burning of fossil fuels, or by industry, or by increased agriculture, or by cutting down of rainforest, etc.? Well, climate change activists and so forth would call this the enhanced greenhouse effect. And with this enhanced greenhouse effect, we are going to predict dire consequences. Keep in mind that those 4 tactics of environmentalism that are employed by environmentalist activists play a big role in this climate change issue. Remember, they're going to manipulate their data, and I'm going to show you illustrations of that. And then they make dire predictions. Here are the dire predictions of the climate change controversy. We would predict extreme weather, an increase in extreme weather. We'd also predict droughts, melting ice caps, as we've seen, and then flooding coastal regions. So let's look at these dire effects that are predicted by environmentalists. Extreme weather, that would be an increase in global hurricanes, an increase in tornadoes, and other violent storms. That is a prediction of climate change. Drought, frequently you'll see pictures of dried out earth and so forth. And are we going to see increase of desert regions? Are we going to see melting ice caps? Here's Greenland. Here's 1992. Of course, when we're starting the height of the global warming. Here's 2002 and 2005. What about coastal flooding? I borrowed this from Al Gore, from his materials that he used for the so-called documentary Inconvenient Truth in 2005, 2006. Here's the state of Florida, and here's the dire prediction. He actually predicted a 20-foot rise in ocean levels, predicting that parts of Manhattan and especially parts of Florida would be underwater. Here's the graphic. So we're losing the entire tip of Florida according to this computer model. Is this happening? Is it going to happen? Are we going to see an increase of 20 feet? Well, most scientists, Al Gore certainly is not a scientist, most scientists have distanced themselves from those predictions and of course would not predict such a drastic rise in sea levels. So what is really happening with climate change? There are 4 things I want to go through with climate change, global warming, or whatever you want to call it. And I want you to keep in mind that many of the things that are portrayed, especially by the entertainment industry, people like Al Gore and now Leonardo DiCaprio, all of these things are just very poor science. They're not going to stand up to real scrutiny. All right, so what's really happening? The first thing I want to talk about with this whole issue and how it's portrayed, mostly with how it's portrayed, is the fact that your global warming or climate change proponents are using a poor analogy, which of course is the greenhouse. They use poor science, and how I know they use poor science is the fact that they have to continuously revert to propaganda, and they have to continuously attack people who disagree with them. That to me shows me that their arguments are weak. If we have to resort to dramatic pictures, if we have to resort to a computer model that shows half of Florida underwater, if we resort to those tactics, that to me makes me suspicious. What aren't they saying? What do they really have? What is the science? So we have the poor analogy of a greenhouse. We have the poor science that must revert to scare tactics and propaganda and faulty computer models. And then we have poor predictions. We do have to predict dire consequences, or people aren't going to do anything about their so-called carbon footprint. And then I think that this whole issue is a poor excuse that that's going to be used to advance certain political agendas. So let's begin with the poor analogy. Is the Earth really like a greenhouse? All right. Do the greenhouse gases trap heat as efficiently as glass in a greenhouse? This is a poor analogy. I think it completely ignores the complex interactions between other climatic factors. I think it ignores wind patterns. I think it ignores the fact that a lot of these greenhouse gases are not man-made. So is the Earth really like a greenhouse? I think this understates the complexity of the atmosphere and the complexity of the interactions of different parts of meteorology. It oversimplifies it at best. That's why I'm saying that the greenhouse is a poor analogy. It oversimplifies it. So is the Earth really like this greenhouse? Well, how does an actual greenhouse work? We know that the glass traps heat, much in the same way that the atmosphere does. But when we're dealing with a greenhouse, we're dealing with glass and we're dealing with a confined space. We're not dealing with a dynamic global atmosphere. Keep in mind that the atmosphere is global. Keep in mind that there are complex interactions between many, many different factors, and that the greenhouse is an oversimplification at best. Okay, so glass traps more heat than the greenhouse gases of the atmosphere. Glass is not dynamic as the gases of the atmosphere. It doesn't change. The same pane of glass is in the greenhouse year after year. Also, you saw my little greenhouse. Are there other factors such as convection currents in a greenhouse? Well, if you've seen a larger greenhouse, you've probably seen built into the greenhouse, you'll have a bank of fans so that they can bring the temperature down and control it and distribute it better. So when we're dealing with a greenhouse, we have to set up our own artificial wind currents to control and disperse the heat. And also, we're dealing with a very, very small area. So the temperature, the heat that's being trapped is going to raise the temperature much more quickly. You're all familiar with a car in the summertime with a black interior and how quickly and how dangerously that heat will rise in a very short amount of time. So the temperature in a greenhouse is going to, the glass of the greenhouse is going to affect the temperature inside the greenhouse at a much faster rate in a much more dramatic way. So a poor analogy. Is the Earth as much like a greenhouse as we say it is? So that's the first problem with our whole issue here. especially the issue of how climate change or global warming is being portrayed by the news media, being portrayed by the entertainment industry, and even by educational institutions. So the greenhouse, I believe, is a poor analogy. It's too simplistic. Then poor science. I think another thing with poor science, as I said, is going to end up using propaganda, scare tactics to try to hide the fact that what they say is going on is not going on at the scale that they say it is. One thing that I said about the tactics of environmental activists is the idea that they manipulate the facts. And you can see that it's relatively easy to make a graph look like what you want it to look like and say what you want it to say. So here's just random data that was generated, and that looks like a pretty dramatic increase. Well, let's back up a bit. Here's that same data curve, the same data curve as portrayed in the first slide. On this particular graph, you will notice that the x-axis and the y-axis are scaled in the same manner. So when I scale the x-axis and the y-axis in the same manner, I get a very boring curve that doesn't really tell me a whole lot. And you can see how it's grouped around 2. We've got graduations a little bit up, a little bit down, all clustered around 2 on the y-axis. What happens when I shift the y-axis so that I can get my data to look better? Here's where I stretch the y-axis to the same, I've got stretched to the 100th of a degree rather than the 10th of a degree. You can see I can make my graph look very dramatic just by manipulating the data. Does that happen? Absolutely. Case in point, the movie Inconvenient Truth. And I am calling that a movie rather than a documentary. So if we look at those two things side by side, you can manipulate graphs. So don't trust every graph that you see. You need to take a look at what it actually is portraying. So when we change the y-axis, we can make the graph look and give an impression that is completely not true. So also we said that poor science resorts to propaganda. There is the required, I think, the required picture of a polar bear being perched on this dramatically decreasing iceberg. I believe this picture was actually computer generated, as was this one, obviously. This is another use of propaganda, and your environmental activists use these pictures all the time. They try to make it an emotional appeal, the poor polar bear, or the fact that this is what we're facing if we don't do something right now about global warming or climate change. And of course, our poor science not only is going to manipulate and massage the data, the poor science will resort to propaganda, and poor science is going to use computer models that are biased. There's the coastal flooding of Florida computer model. That computer model is biased. That's biased to show a 20-foot increase in sea level, something that simply is not happening and cannot be predicted. So the environmental science that is frequently portrayed by your weather alarmists, your climate change alarmists, is based on poor science that's using a poor analogy, that's manipulating statistics, and so forth. Here's the third idea. Many times the science used to promote global warming or climate change makes poor predictions. Okay? Does the computer model accurately portray reality? That's a question that you need to examine when you're looking at computer models. Does it predict reality accurately? Or can we even predict what's going to happen? Here is an example of the fact that global temperature increases simply are not happening. And that, of course, is why we don't call it global warming much anymore. We were going to refer to it as climate change. That way it doesn't matter if it's warming or cooling. So here's what's happening with the computer model versus observed data, actual increases. And again, pay attention to the scale. The scale is right here at 0, and we're dealing with temperature increases, and we are still dealing with that 2 degrees Celsius as being what is predicted as the increase in global temperature, 2 degrees Celsius. And again, what measure? How was this measured? Which one are we talking about? Are we talking about temperature anomaly? Are we talking about temperature deviation? Are we talking about global temperature average? Which one are we talking about? A lot of confusion there. All right, so here's where we should have been in 2010, 2012. Here's where we are. Okay, so the thing that you need to realize is that the predicted temperature increases simply are not happening. And that's because the Earth is doing what the Earth has been doing for decades and decades, experiencing cyclic trends, warming, then cooling, then warming, because the atmosphere is very dynamic. The atmosphere is always changing. It's not static like the glass of that greenhouse. I think the greenhouse is a big oversimplification of just the properties of the atmosphere and the dynamics of the atmosphere. So we're kind of falling off the scale of what our computer models have suggested were going to happen. Another thing that was predicted is extreme weather. Are we seeing an increase of hurricanes? Did the number of hurricanes increase over the last several years? Here's a graph of global hurricane frequency and intensity. All right, doesn't look like it's increasing too much to me. It looks like it's actually decreasing. But again, are we even able to predict these accurately? And do we have a scientific link between temperature rising and increase of hurricanes? Here's another poor prediction: increasing number of hurricanes and an increasing number of tornadoes. Have we seen an increase in tornado activity? Maybe we have, but again, it's something that is constantly changing. And is it a result of global warming? Don't know. But it's not what is being predicted. It's not the extreme weather that is being promoted by environmental activists. So global warming, is it really happening, or is it just a scare tactic? Is it just a means to an end? Is it just part of a political agenda? Well, I think at best, global warming, climate change, climate crisis is a poor excuse. It's a poor excuse for drastic measures. It's a poor excuse for increased government intervention. So does the government need to get involved? Can the government do anything about it anyways? It's also, I think, a poor excuse for making drastic changes. Do we need to cut our carbon footprint? Do we need to restrict vehicle emissions? Do we need to put more regulations on industry? Do we need to abandon coal-fired electrical plants? Do these things need to occur? I think what's happening is we are simply not seeing the dire consequences predicted by environmental alarmists. We are not seeing surface temperature significantly increase over time. We're seeing what the atmosphere normally does, and we're seeing warming trends, cooling trends. We are simply not seeing a consistent increase of global temperature. And a lot of the techniques, you need to question what you read. You need to question what you hear. You need to question what you see. Is this really happening? What is the science behind it? Who is involved with it? Because when we're dealing with climate change, we are getting the same environmentalist tactics that we had. What began as global warming in 2000, due to a warming trend in average global temperature, was actually even following the 1970s and 80s when we had the dawn of the new ice age. These are just predictions of environmentalists. And of course, now we're going to call it climate change. We're renaming it. We kind of want to downplay and hide the fact that far less warming is happening than actually was predicted. So when we're dealing with climate change, it is the same old global warming with a new name. And the environmentalist view of these environmental issues is simply that environmentalists are convinced, they have the belief that the activities of human beings are responsible and that the government needs to get involved. The government must do something about it. The government needs to be involved globally with other countries and needs to be involved in international initiatives to decrease carbon emissions and so forth. We need to make changes in our lifestyle. We need to eliminate the use of fossil fuels. Now, some of these things are a good thing. Some of these things would be very in line with what we call our stewardship initiative as far as how we view our environment. On the other hand, we don't swing way over to the right and say, well, who cares about the environment? Let's use up all the coal. We're not talking about that. We are talking about the fact that global warming is extreme. Whether we call it that or we change the name to climate change, it's extreme. The science behind it doesn't stand up to scrutiny. The science behind it is suspect. And of course, the predictions behind it are extremely suspect, to the point that we would call them propaganda. And environmental activists are blaming the wrong causes, just like we've said before with tactics. This is especially true of global warming. Environmental activists are going to blame overpopulation. Environmental activists are going to blame the use of fossil fuels, especially those coal-burning plants to generate electricity. And they're going to blame auto emissions and urban sprawl and deforestation and agricultural expansion. Are these a problem? Especially urban sprawl, urbanization. Is it a problem? Yes, it can be. And it can cause very drastic environmental changes, but on a local scale. We're not dealing with a global climate crisis. And the effects of global warming are sensationalized, particularly by the entertainment industry, but unfortunately even the news media gets on the same environmental bandwagon, promoting the coastal flooding of Florida or New York City as the ice caps melt and as we have polar bears becoming extinct because their habitat is being destroyed. What are these things? These are effects that are overemphasized and sensationalized by people who have a very extreme environmental viewpoint. Extreme weather. Are we experiencing increased flooding and drought? Are we experiencing high temperature deviations from the normal? Is that happening? What about severe storms? Are we seeing an increased amount of tornadoes and hurricanes and so forth? I simply think that the science behind much of this alarmism is simply not there. And of course, we have solutions to global warming. We can reduce the use of fossil fuels, and there's nothing wrong with that. But I just don't think that we need to go to the extreme measures that are being promoted. I don't think we need to make these drastic changes. I think it's a poor excuse. The reduction of auto emissions is a good idea, but what's the way to reduce auto emissions? Restrict the use of vehicles during certain times or certain days of the week or in certain places. taxing gasoline and taxing the use of your higher, less efficient, higher performance vehicles? No, I think the answer to that, it is a good idea to reduce auto emissions, but the answer to that is new technology. Let's work on the hybrid automobiles. Let's work on electric cars. Are they efficient? Oh, wait a minute, electric cars. How much electricity is that going to use? Is that going to then put a strain on the electric grid and so forth? All of these things. The answer should not be increased government intervention. Do we need the government involved? No, I think we need good old-fashioned American ingenuity. I think we need innovation. We need research and development into more efficient engines, more efficient ways to produce electricity, and so forth. All of these things, if we try to force people into making drastic changes, and we force industry into making drastic changes, are simply going to result in an unfavorable, to say the least, impact on the on the economy. And I really don't even think that all of these measures will make that much of a difference. The atmosphere is simply too complex and too dynamic. So, it is a poor excuse to make drastic changes. It is a poor excuse to take drastic governmental intervention. And do we need to be worried? Let's go back to this. Do we need to be worried that the earth is going to burn up? Well, if you're a Bible-believing Christian, obviously not. We go back to what God has said in the Bible in Genesis 8:22. While the earth remaineth. While the earth remaineth, we are going to still have, according to Genesis 8:22, what are we going to have? We're still going to have heat and cold. We're still going to have harvest and seed time and harvest. We're still going to have summer and winter. We're still going to have day and night until God ordains judgment, as we saw in 2 Peter. Here's the verse, Genesis 8:22. While the earth remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night, and God promises shall not cease. So there are man-made activities are not going to make man-made greenhouse gases, human activities are not going to make the atmosphere lose its heat-trapping properties or even increase its heat-trapping properties. The earth is going to continue on until the Lord changes that.